Hi, this is Hector, Alphacam Brand Manager, and welcome to Top 10 Reasons Why You Want to Upgrade Your Essential Router to your Standard Router. This is reason number 1, solid simulation. If you currently have an Essential Router license, you notice that you are capable of generating what we call a wireframe simulation. However, unfortunately, this simulation does not let you visualize the effects of the toolpath on the part. You're only able to see the motion of the tool, and then you really have to use your imagination to go ahead and see what the effects of that will be on the actual material. As you can see from here, although this is a very valid simulation and it is giving me valuable feedback, I am missing out on a very important feature, which is what I'm going to show you right now. With the use of Standard Router, you'll be able to go ahead and summon what we call the solid simulation. The solid simulation doesn't just show you the motion of the tool, but it will actually show you the effects that that specific tool will have on the part, even if the tool has a custom shape, which is what I want you to appreciate right now. The tool is a V-cutting type tool, and it's actually carving the Alphacam logo. You'll be able to see the effects of that tool on the actual carving operation. I have a secondary operation here for those of you who think that, oh well, that's because it's just a carving. The secondary operation is a shaper tool that's actually going around the perimeter of the part. You'll see that that also has a custom shape. Let me pause it so that we can appreciate the shape of the tool. So as you can see, this is a classic OG, and it has a dual purpose, to cut the perimeter of the part as well as to put that decorative feature on. You'll be able to see how the decorative feature is actually impacting the material. And then when the simulation is complete, you'll be able to do really interesting things, such as generate a cross-section of that simulation. And you can actually scrutinize it. You can take a look at whether you're getting what you want, you're cutting too deep or not deep enough, as well as to be able to save it and then share this in STL format. This is reason number 2, enhanced nesting. For those of you that actually do nesting on a regular basis, you'll see that Standard Router brings enormous benefits over Essential Router. For example, immediately identifiable is the ability to create as well as reuse nest lists. You will be able to go ahead and create ahead of time lists that will allow you to very expeditiously do the nesting process. So you will be able to go ahead and define ahead of time the quantity of the materials, the rotation of the materials, as well as any special priority or kit part numbers inside of those materials. And this will allow you to very quickly accomplish the nesting, as you can see that I'm doing right now. I didn't have to configure my parts. I didn't have to tell it how many of each individual part. It was simply load the nest list and go. As soon as we process the results, we're processing results to get also bridged part nesting, which is another one of our advantages in Alphacam. So there you go. You can see that I have rectangles, circles, and a triangle in there. Now, this is great, but I also want to show you a very important advantage of using nesting in Standard versus the classic one. I'm going to go ahead and just start from scratch, drawing a sheet and basically just inserting some parts into the screen. This is certainly one way that you can accomplish nesting. In Essential is the only way that you can accomplish nesting, because you don't have the ability to do nest lists. You have to do the nesting basically from the screen. Now let me go ahead and show you the advantage. I will be able to go ahead and, just like before, you can define the shape that you want to nest, right? And you'll be able to define the properties for that item. Like you can say this is a triangle, right? And I need 16 rotated anyway. This is a circle, and I need 22. And then this is a square. and I need 11, right? In normal essential, if you made a mistake with any of these parts, you're basically in trouble. Now you have to start all over, even if you were down to part number 75. Here, I have the ability to quit, as you saw me do. And for example, I made a mistake with the circle. I allowed rotation of any angle, which really doesn't make sense. I should say don't rotate. Now, just keep going down this road with me, and let's say that I didn't want 22 circles. I wanted 18. You can see that I can make those changes on the fly, right click, nest, and go directly to the geometry of the selection of the sheet or sheets, and immediately go to the nest. I took the bridge part nesting out just to make the video a little bit shorter. Okay, but you can see that I have that. Now you can probably say, oh, you know what, I just want to go ahead and put 3 more circles in there so that I get sheet number A3 completely done. Well, you can just go back here, configure, put 21, nest it again, go to town, and so you'll be able to see how the enhanced functionality in nesting is truly worth, I think, the upgrade. This is reason number 3, horizontal milling and drilling. You see, in regular essential, you will not be able to go ahead and create what we call workplanes. So you will not be able to take advantage of any aggregate machining as well as any horizontal drilling. So being able to create what we call workplanes and define additional complex machining on horizontal faces of a panel is one of the fundamental reasons why you want to go ahead and upgrade your essential router to standard. For example, these are 2 typical applications that we may potentially see with an aggregate. This could be putting some kind of decorative edge on the side of the panel, right? Alternatively, for people in the window and door industry, you will also be able to do things such as hinge pocketing as well as pilot hole drilling. This is reason number 4, profile machining. With standard router, you'll be able to go ahead and create complex profile shapes, even if they're custom, like the one you see right here. This is a request that I get a lot of. For example, we have an existing custom profile that was created a long time ago, and now we are replacing a portion of it, and on top of that we have to have an arc that kind of blends already into the existing geometry. You could do this on a shaper. However, you would have to get very involved creating the custom knives that your molder or shaper are going to need to be able to run this profile. If you have that need, Alphacam will allow you to create this complex 3D data by creating minimal geometry. To give you an idea, the only geometries I had to create here was the actual shape of the molding and a cavity geometry where I'm going to be removing excess material, as well as, of course, the profile itself, which is the geometry in blue. Just by generating these 3 geometries, I am capable of basically hogging away excess material as well as applying that custom profile, and these are the operations I'm going to show you. When I run a simulation, you'll see the first operation is the operation that I'm using to just hog away the center of the part, which I don't necessarily need. Now this is optional. Of course, if you were to bandsaw or somehow remove the front of that material, you wouldn't have to have your CNC hog away excess material. But I'm doing it for the purpose of the video. This secondary operation is a roughing operation where I am now beginning to bring down that profile into steps that are, I think, about 6 millimeters or 1/4 of an inch deep. At that moment in time, we switch to a 1/2 inch or 3/8 of an inch ball end mill. And this ball end mill is going to take steps little by little to go ahead and begin giving us that custom profile that we're looking for. Once again, even though this is clearly 3D information, I only had to draw 3 separate 2D geometries, right? I'm gonna go ahead and speed this up so that you don't spend a bunch of time just looking at that. There you go. The next operation would be obviously taking care of the perimeter of the part, and that's what we're going to do here. So this is a 3/4 inch long finisher. To remind you, 100% of the tools that you're looking at over here are commercially available. And so what I'm doing here is called a helical operation, which is going to continuously go down, right? Which helical operation is another advantage of standard router. At that point, I actually inserted a pause in my program, what we call program stop. That's what this is. And through a properly configured post processor, I would be able to approach the machine, remove the excess material, and continue my operation. And basically the last 2 operations are only giving us sharpness, right, where the ball end mill was not able to do that. Just like before, I can show you that there's the ability to create a cross section. We can take a look at that. And so, in a nutshell, there you have it. Reason number 4, profile machine. This is reason number 5, the Parametric Sketcher. In standard router, you'll be able to go ahead and create templates for parts and families of parts that you recycle, that you use a lot. So for example, I created personally this one here, which produces, this is a panel for valence or some artistic panel that you may want to do repetitively. Notice that all I have to do now that I've created the model is change some of the variables. This could be 60 inches long, for example, right? And I hit enter. This could be 16.5 inches wide. And you can see that I've created additional variables to help me control other design features. For example, what I call the arc height, that could be 5 inches. The straight section could be 12 inches. And if I like that, all I have to do is hit run, and that actually places that drawing directly in Alphacam for me. This is a fantastic way of saving time. There are additional samples in there in case you want to see how some of these other parametric sketches are created. For example, you'll find built in the system there's a polygon, an arch door. Here's, for example, a star, which is fun. You have the control over the different parameters of the star, and just like before, you go ahead and you hit run, and it draws the geometry for you. So for those of you who are looking for a way to automate the drafting of a repetitive part, the Parametric Sketcher is certainly a way that can get you there, and it's certainly a way that we can justify updating to standard router. This is reason number 6, the waves add in. You have probably noticed that over the last 3 to 5 years, architects have been designing these interesting and compelling wall treatments. You see them in airports, you see them in courthouses, you see them in multi-million-dollar homes. In order for us to help everyone have an amazing wall panel, we've decided to open up the design capabilities of the waves add-in to you. This is a button that takes what is essentially a very complex procedure and allows you to simply set up some parameters, as I'm going to show you, and select a boundary geometry, and just like that, you can create very compelling patterns and information. You don't need to know anything about 5 axes, you don't need to know anything about 3 axes. You just push the button, populate the parameters, and off you go. To give you an idea, we're going to be using a simple and commercially available round ball end mill. Right? This is a simple ball end, and we're going to be cutting at a depth of 1/4 of an inch. And I'm going to go ahead and show you what that simulation looks like. I will remind you that, for example, this simulation is only 2D toolpaths. There is absolutely nothing that is 3D in here. We're achieving this interesting and compelling looking pattern by simply using rough or finish on the geometries that were created by the Mac. And I'm sure you'd agree with me that this looks really, really interesting, understanding this is nothing but a bunch of lines and arcs that happen to be machined with a ball end. Right? Now, of course, the interesting aspect of the macro is that these settings that we have here can be stored and you can retrieve them for different purposes. So those settings I called sample 1, but I can drop the list and go to sample 2, and this is going to give me a completely different look. Likewise, small changes to the settings can give you a great difference in what you're looking at. Now, of course, the purpose of this video is not to teach you how to use the add-in. It's just to show you the capabilities that are behind it. Once again, same add-in created the same geometry. So we're going to get a completely different end result. I'm going to pause it and get to the bottom of the simulation. And here it is. So once again, you probably agree with me, this is a very interesting looking pattern, and I didn't have to know anything about 3D. I didn't have to know anything about complex design. I just ran rough or finish with a regular tool at 1/4 of an inch depth. Okay, the other possibility that's available to us is creating actual 3D information, which is creating waves in the Z-axis. This macro, or this button, allows you to quickly just go ahead and select the parameters just like I did before. This is the longitude of the wave, the amplitude of the wave, the top and the bottom of the wave, any offsets between the different sections of the wave, and I can go ahead and click OK, and I can go ahead and select a geometry, and just like that I can generate 3D polylines. These 3D polylines or splines can then be machined with the cut spline or polyline button. I'm going to be cutting 1/4 of an inch. So now, just like before, we're going to go ahead and run the simulation. And this is the pattern that I would get by running that particular set of settings. Now, let me go ahead and backtrack it. I'm going to close it. And I'm going to undo and undo, and this time I'll show you the exact same set of settings, but with a distance between waves of, say, 3/4 of an inch, can give me a completely different visual result. Once again, I'm going to apply that commercially available cutter, which is the ball end tool, and this is going to give us a really interesting application. There it is. Let's look at the simulation. There you have it. Now look, both of the buttons, right, create the geometry for you. I'm pretty sure that if you take a look at it, you'll agree that this is an interesting pattern. And once again, I was able to achieve it without having to know any 3D drafting techniques. The last button that is available to you is applying the waves in the Z to an existing geometry of your fabrication. So as I was telling you, both the X and Y waves as well as the Z waves but actually create geometry for you. This third and final button does not. It is basically assuming that there is geometry already on the screen that you created, like these lines that I'm creating right now, and I am literally randomly clicking anywhere on the screen. There's really no methodology or science behind what I'm doing here, and I can then go ahead and apply this button. So as I was telling you, Likewise, you'll be able to set up the parameters for the wave, the top, the bottom, amplitude, and longitude. And then you can simply say OK, select them, and you'll see that even from the top view, they look identical to the geometries that I drew, but now these are 3D polygons. If I look at the front view, you can see that now they are complex geometries, and the parameters for the waves came from the parameters that were set up here. Finally, once again, applying that commercially available cutter, maybe to a depth of 1/8 of an inch, will render an interesting looking panel. So the possibilities are truly endless. You can go ahead and create all kinds of interesting information by having minimal amount of time spent designing the different features. And these features are the ones that are important to us. Let's go ahead and run the simulation. And there you have it. These are very interesting patterns that are not just using the XY pattern, they're also actually moving up and down in the zoom. And this is reason number 6, the waves adding. This is reason number 7, surface machining. With the use of standard router and higher, you'll be able to actually create 3D surfaces. These 3D surfaces can really come in a variety of presentations, and we have most commercially available ways of creating a surface by sweeping, by patching, by ruling a surface, making a surface from revolution. And then the example that I'm going to show you right now, it's a very simple extruded surface. The application that I'm going to show you is a guitar body, where we're going to be carving, that's what we call it, a carved top guitar. What you will be able to do is what you see here in this first operation. You'll be able to go ahead and define that region which is curved, and then you'll be able to define a boundary that will prevent that cutter from carving away outside of where it needs to. For those of you watching the simulation and thinking that this is basic, indeed it is. Our advanced level of the software has a very comprehensive set of tools to go ahead and do work in 3D. But if there is such a thing, this could be regarded as your entry-level surface machine. Of course, whether you create the geometries here or you're actually importing the geometries from third-party software, you'll be able to go ahead and machine those surfaces. Once again, a small disclaimer: if you're going to be working with solids out of any type of Boolean solid kernel, you definitely want to use the advanced level of the software. This is for surfaces only. Let me go ahead and get to the end of this particular simulation. Okay, now that the ball end mill has done its work, we can go ahead and see what would be the final intent of this. Here's another one of those advanced techniques that is available to you in standard, not in essential, where we can go ahead and use helical machining. As you can see, the cutter never leaves contact with the material. It's just one giant ramp going all the way down to the bottom. This is perfect for this type of application. It's also very efficient because the tool never leaves contact with the material. When we get to the end, we're just going to be pocketing the pickup and the neck cavity, and we're going to take advantage of double tooth pocketing to take account of previous machines. Once again, this was something that looks very complicated, but in reality we were able to draw a simple 3D surface. Go ahead and show you the cross section, and that allows us to go ahead and do things that would be regarded as difficult, but in reality it was a simple 3D machining method. This is reason number 7, surface machining. This is reason number 8, sawing. While it's really easy to apply sawing in Alphacam, it's actually not a trivial thing. The utility has a number of features that allow you to take what is the complex process of calculating saw positions and angles and contact points and so on and so forth, and it makes it very simple to apply. For example, all I have to do to go ahead and cut this octagon out is basically set my tool direction, and I can go ahead and apply sawing. As with anything else, it can be partial or elemental. We can even saw internal arcs. It can be manual or it can be automatic Z, depending on whether we actually apply geometry Z levels. But here's the interesting thing. The feature will automatically identify what type of element or what type of feature we're cutting, whether it's an internal corner, an external corner, or open ends. Open ends, of course, being individual elements or individual geometries, not a closed perimeter. So for example, on external corners, I could say cut to the line, and it will do what it says right there. The edge of the blade will stop short of each external corner. Cut on the line, so the center of the rotation of the blade will stop at the end of the element, or cut past it by whatever distance we want to specify in here. Then we can go ahead and set our safe levels as if we were just simply working with a geometry on flatland. Then we can go ahead and apply the machining. Notice that we also have the ability to avoid fouling, which I will explain in a minute. Anyway, that's it. By simply applying that, now I have the ability to go ahead and set up my saw cuts, and I'll show you the simulation so that you can see what we have accomplished. So basically the tool is automatically managed for you. Every one of the cuts and every one of the directions is basically taken into account for me. And apparently I also machined the outside of the material, which I didn't want to do, but it also shows you what you can do here. Now, let me go ahead and undo that. I'll show you how easy it is to go back and simply put, say, a 45-degree bevel on that. Let me go ahead, I'll set up my material ahead of time. And so without having to do any type of calculation, I could just go down here and put a 45-degree bevel. Right? Obviously we also have the ability to select individual geometries in case we wanted to apply the machining to all of it. We could say select it. And so let me show you what the bevel looks like. And every one of these features is of course under your control. The safe rapid level, the disengagement, etc. And that's actually going to give me what I was looking for. Now you can also go ahead and easily extend them, and you can also use the stock to be left to go ahead and make a bigger or smaller feature by simply moving this number. So if I say, hold on, it needs to be an inch smaller and I need to cut a 1/4 inch deeper, you'll notice that now I was able to go ahead and generate essentially a smaller octagon. It's 1 inch smaller than the original green geometry that I drew. But nonetheless, there it is. So for those of you that actually have the ability to use some kind of sawing information, the sawing command is a big deal. And again, one of the reasons why I think you need to consider upgrading to standard. This is reason number 8, sawing. This is reason number 9, STL Utilities and the ability to do 3D part move, rotation, and modification. Continuing the conversation of being able to do 3D surface machining, 3D solid machining, simulation. In other words, we're moving the application into the realm of more advanced objects. The STL Utilities is something that has become very popular. For example, if you're working with artistic endeavors or carvings, or a file that you can potentially purchase from a third party, whether it's scanned or from a website, STL is a very popular format for the developers of those files because it's not easy to change. And so when they share that file with you, they're kind of protecting their intellectual property. The example I want to show you today is I'm dropping an STL file, which is going to be just a chair leg that you can see here. So the first thing that is important to be able to do in standard is to be able to go ahead and move this part in 3D. You'll notice that when I execute the move command, I'm not just moving X and Y, but I'm also moving Z. That's important. I can reposition that to 0, 0, 0. And once I have it in here, the other important thing is that I can rotate. And when I rotate this object, I'm rotating it in space. Therefore, it's asking for an axis of rotation. I'm going to say 90 degrees. Perfect. Now, the other thing that's going to be important for me is I need to figure out, well, how big is this? What is the size of the piece of wood that I need to order from the mill? And this is where the STL Utilities begin to help us. We have the ability to create an enclosing rectangle immediately on it. And that is what's going to allow me to position this in the right location for machining. In this case, I'm just going to go to the bottom left corner and make that 0, 0, 0. Now, there are a number of utilities that I have here, depending on what is it that I'm trying to do. An important one is, for example, being able to simplify an STL. Sometimes you get a scan, and that scan is literally millions of tiny lines, and it's making it difficult for me to work with. This is showing me those facets of that scan. For example, simplifying the STL can allow you to basically tone down the model so that you don't have to deal with something that is very, very dense if your intention is only to like pre-carve it and then give it to somebody else, right? You can see here that we have the options for simplification, and you can see the result. We're going to go from something that has very small facets to something that has more facets. We can keep the original STL in the event that we want to use it for, say, roughing. At any rate, being able to work with STL so that I can subsequently apply roughing and machining is a very important feature, and why I'm calling it reason number 9, STL Utilities. This is reason number 10, the file insert. Another key feature that you're going to find in standard that you will not find in essential is the ability to use the file insertion tab. This tab is available on the left hand side, and you can see it through View, Project Manager page, File Insert. Now, you'll find that for those of you that have the need of dragging and dropping into the screen a repetitive pattern, this saves you a tremendous amount of time. I can drag it and drop it, and immediately you can see a preview of what you're dropping, and you'll be allowed to give the coordinates, as well as transform the object by rotating it. And you will also be able to deform it by stretching it or scaling it. Once the object drops on the screen, it's conveniently grouped together so that you don't have to be hunting for individual geometries. This is very powerful for those of you that are actually looking at specifically telling it how to grow, where to grow, etc. Those of you that are doing decorative features will also find it very, very convenient, right? Because we can bring these flourishes, I can see what they look like even before I bother bringing them in. We can also use this for simple geometry, and there's other applications, of course. You could be bringing in machine pods or clamps or other features that are potentially something you want to drag and drop into the screen. Now, beyond that, if you don't feel that decorative justifies the utility, there is another very powerful feature. For those of you that are creating hardware files, and what do I mean by that? I mean hinges, I mean lock screw, I mean anything that is a fixed piece of hardware that the machining has to be repetitively applied at different locations on a part. What we can do, instead of actually inserting, for example, this will be an example of a jam that's going to get 4 different hinges. And instead of inserting one by one all the time, what we can do is we can create what we call a layer map. This layer map will take the specific hinge that I'm dragging and dropping, and will automatically associate it with the center of the circle located in the hinge called, the layer called hinge, I'm sorry. So when I drag it and drop it, boom, it automatically positions every one of those and replicates it on every one of those circles, and it does so automatically. And so this saves me a ton of time and potentially mistakes by putting the hardware in the wrong location. To show you how this is going to work, I can just simply copy this circle and populate it somewhere else, and when you drag it and drop it, it automatically puts that particular drawing inserted into that circle. This, again, I say, saves you a bunch of time, bunch of mistakes, and it's why I nominated for my reason number 10. This is the file inserter. And this actually gets to the end of our list. I hope you enjoyed the Alphacam top 10 reasons why we want to go ahead and upgrade to standard, and you do consider upgrading to standard. This is Hector, and it's been a pleasure to show you this information. Bye.